of this course is for us to learn how the different tools of mathematics can be used to help us solve problems. So we're focused on these applications. So let's take a few minutes here to see some of the applications of these right triangles. Anytime that you have a right triangle, there's 3 sides and 3 angles. And as long as you know 3 of the 6 parts, and it doesn't matter if it's all 3 angles or 1 side and 2 angles, 2 angles and a side, all 3 sides, as long as you know 3 of those 6 things, then you can always find the others, as long as one of them is a side for today. Now, after we finish the next chapter, it will be okay if we don't even know any of the sides. But for right now, we do need to have at least 1 side, and then we'll be able to find all of the remaining parts. So to solve a right triangle, you have a right triangle and you know 1 side and then 2 other pieces of information about it. How do we find the missing pieces of information? So the first one is if you know 2 angles, the third angle can simply be found by knowing that the sum of 3 angles is 180 degrees. And so if you take 180, subtract the 2 angles that you currently know, you'll have the missing angle. Now, if you know 2 sides, you can find the third side using Pythagorean theorem. And that's your a squared plus b squared equals c squared. Now, if you know 1 side and 1 of the acute angles, then you can find the other side by using a trig ratio. And that's your sine, your cosine, and your tangent. Now, you certainly could use cosecant, secant, and cotangent, but since those aren't buttons on the calculator, it's easier to set up either sine, cosine, or tangent. And then the last case, if you don't know either of the angles, but you do know 2 sides of the triangle, you can actually find both acute angles by using those inverse trig ratios. That's going to be your inverse sine, your inverse cosine, and your inverse tangent. So let's work on a few examples to help us see how this would work. So in example 1, we know the hypotenuse is 16. I always draw a triangle, it just makes it easier for me to see what's going on. We know one of the acute angles is 35 degrees, and we want to find the other acute angle in the 2 sides. Now we know this was a right triangle, so I knew automatically that across from the hypotenuse was going to be a 90-degree angle. So I can find the other missing angle here by doing 180 minus 90 minus 35. So that tells me that I'm looking at a 55-degree angle. Now to find the different sides, I'm going to label them X and Y just so that I know which one I'm referring to. So looking here, here's my angle 35 that I'm given. I could certainly do this from 55 degrees. It doesn't matter. I'm just going to stick with my 35-degree angle here. I could say that the sine of 35 degrees is equal to the opposite, which I don't know, and I've labeled X, divided by the hypotenuse that I know is 16. And so now we have a fraction equation to solve. I'm going to multiply both sides by 16, which will get my 16s on the right to cancel, and that tells me that X equals 16 times sine of 35 degrees, and I type that into my calculator, and I see that my side X is equal to 9.177. And now let's find the other side. Here, Y is representing the adjacent, and so it's cosine that gives me a ratio of the adjacent to the hypotenuse. So notice here, I've set up a trig ratio with the side that I know and then the side that I'm missing. And I decide, do I know the opposite and hypotenuse? So then I would use the sine. Do I know cosine? Do I know the adjacent and the hypotenuse? That's where I'm going to use cosine. Or do I know the opposite and the adjacent, in which case I'll set up tangent. So it all depends on the side you know, the side you want, to help you decide, do I use sine, cosine, or tangent? But to find y, that's the adjacent, and we know the hypotenuse, so we use cosine. And to solve this equation, we multiply by 16. And so 16 times cosine of 35 degrees gives us side y. So multiply that in your calculator, and we're looking at y equaling 13.106. Let's do another example. We have a right triangle and we know the two legs. I know one leg is 5.00, the other leg is 8.00. Now I don't know which angle goes with which side here, but it doesn't matter because I'm just trying to find the missing sides and angles. So I know two sides, I can find the missing hypotenuse with the Pythagorean theorem. 5 squared plus 8 squared equals c squared. So that's 25 plus 64, I get 89. And so c is the square root of 89. And since this is an application problem, it's fine to go ahead and do a decimal here. So c is 9.434. If you wanted an exact answer, you could leave it a square root of 89. Both of those are plenty acceptable for this problem. Now I want to find one of the missing angles. So I'm going to label this angle A down at the bottom. And let's take the two sides that were given because those were exact. Those were no rounding. So what sides do I have? I have the opposite and the adjacent. So it's tangent that I would use to set up opposite over adjacent. So I do tangent of angle A equals 8 divided by 5. To find angle A, since I know the tangent ratio, but I don't know the angle, I use the inverse tangent. And so I do inverse tangent of that 8 divided by 5. And I'm looking at an angle that is about 58 degrees. Now, what's my other side? Or not other side, I know all the sides now. What's my other angle? Well, the other angle will be 180 minus the right angle of 90 minus that 58 that we just found. And so we're looking at a 22-degree angle. So my missing side, 9.434. My missing angles, 58 degrees and 22 degrees. Now, if we had an application problem like this in example 3, we had a highway that was 4.20 kilometers long, and it rises along a uniform grade that makes an angle of 3.2 with a horizontal. What that would look like here is that angle with the horizontal is there, 3.2. This is not drawn to scale at all. And the road here would be the hypotenuse. So the question is, what's the change in elevation? So elevation is your rise. So we're looking for that side there. On these application problems, you have to decide what I'm looking for. What side or what angle am I interested in solving for? So in this case, elevation would be that leg of the right triangle. So from this 3.2 degree angle, 4.2 is the hypotenuse, and x is the opposite. So it is sine of an angle that gives me the opposite over the hypotenuse. So I set up my equation here, and I solve by multiplying both sides by 4.2. And so the change in elevation will be 4.2 times the sine of 3.2. And so the change in elevation is 0.234 kilometers. And on this problem, I don't need to find the other side or the other angle because this problem just wanted to know the change in elevation, so we're done.